Hello, I'm Dr. Mirko Pegoraro, and in this video I'm going to show you how to record area measurement of the wing of Drosophila melanogaster using ImageJ. So in this video we will see how to set up the scale in an image using ImageJ, how to mark the region of interest that we want to measure the area of, how to measure the area, and then how to save the data. Okay, so first of all, let's have a look on a Drosophila melanogaster wing. This is one of the pictures that we took in the lab. And let's learn a bit more about the anatomy, or if you want, the geography of this wing. And the information I'm sharing here with you are taken from this paper, Matamoro and Vidal, 2018. So if you want more information, learn more how the wing develop, you can access that paper. So first of all, what are the main axes that we need to consider for measuring the area? We have the anterior and posterior. So this part of the wing is the anterior part of the wing that point to the head of the animal, and this is the posterior part of the wing that will point to the posterior part of the animal. And I think you can notice that this part is where the wing attached to the body of the animal, and therefore is the proximal part of the wing, while this other part of the wing is the one that points away from the animal, so the distal part of the wing. You notice here that we have several structure, or if you want, veins that define different regions of the wing. These veins are called L1, L2, L3, L4, and L5. Then we have pivotal points that are defining region where the veins meet each other, or where the vein meet, if you want, the periphery of the wing. And these are point 1, 2, 8, 6, 4, 7, 3, and 4. There are other points, but for understanding how to measure the different elements of the wing, these are sufficient. So now I have named different regions of the wing totally arbitrarily based on the veins and these pivotal points. So this region here, so we are all understanding when we share information on what we are talking about. So this region here, this section of the wing, I call it the L1, just because it is defined by the L1 vein. This region here, yes, is the most anterior part of the wing. I call it the L2. This other region, you can see it here, go from point 4 to the peak over there, and then all this region here is the L2, L3, because it's the region between the L2 and L3 vein. Then the region in the middle here, yes, from point 4 and 6, and then extended to 3 and 4. I call it the L3 and L4 because it is between the vein 3 and 4. Similarly, this region here is the L4 and L5. This external region, yes, here and all around there is the L5. Then we have this region in the middle here, which are here defined by the cursor, is the P6, P8. And this middle region is the P4, P6. Now, this is how I call them. Obviously, this is arbitrary, but if you call it the same way while you do your measurements, it is easier to share information. Okay, that's good. So now, before we start, or before you start your measurement, I find that it's a good idea opening an Excel file like this one, and add information already about the wing that you're going to measure. For example, you can put the name of the wing, the genotype, the sex of the animal that the wing comes from, the symmetry, whether it is left or right, the treatment, and then the section that you are going to measure, and the area, which will be in millimeter square. So the name, you see, it comes directly from the name of the picture. This is very important because you don't want to keep measuring the same picture because you forget to put the name. Also, it is important because then you will be able to measure different pictures, and you want to have all the measurement from all the different pictures that you are assigned to for your project. The name usually include a lot of information about the picture itself. For example, this is a WT, which is a wild type, and the genotype that we use for a wild type in our lab is Oregon R. Here they say that this is a test 0. It is a F right, so it's a female right wing. So here we have sex is female, symmetry right wing, and the treatment is control. In this case, it was called test 0. In terms of your treatment, the treatment that you will be assigned to, you have to speak with me about the exact treatment or effect that we want to measure using those wings. The other two parts, the section that you are going to measure and the area, depends on what you are actually doing in using the ImageJ software. So you can download the ImageJ software and install it. It is for free. I use the Fiji one. So here it is. And how now are we going to measure the area of the wing that are of interest to us? So first of all, let's open the file. So you can click the file here and open. Then using this drop-down menu, you can navigate to the folder where your images are. So in my case, I need to go to my OneDrive, and I suggest that you save all your data, all your information in OneDrive, so you don't lose it if your laptop or machine break down for whatever reason. And then you navigate to the place where the wings are. So here is the wing project. Size. And here we have several wings. I will assign to each one of you the wings that you need to measure. But just for explaining how to measure the wing area, if you go to this here. And let's open the first one. This one is a TIFF file. And as you notice the name, it is the same that I already wrote in the Excel file. So let's open this one. So open. And here we are. So this is the wing. All right. So now that we have opened the wing, we want to set the scale. It is very important to set the scale because otherwise we will not be able to compare different measurements. All right, and luckily enough, every time that students measure or took pictures of wings, they also set up the scale for the picture that they took. That's great. So usually you have either one or two scale in the picture. In this case, you will have two. So one, you can see it there. So let's zoom it. So if you press this zoom or button, you can zoom in different sections. So you have this red line here, and this red line here corresponds to this value here, 0.29 millimeter. So that red line corresponds to 0.29 millimeter. Also, often you also have a scale here, and if you zoom in, you see that the distance between this point and that point is 0.11 millimeter. So I prefer to use this as a scale. So what we have to do is to set up the scale. So first of all, to set up the scale, you need to press this function here, which is the straight function. Press that, and then you press 1 near the place to define the distance, that is 0.11 millimeters, as such. And then you go to Analyze, Set Scale, and then you say here, distance, the known distance is 0.11, and here the unit is millimeters, okay, mm. Okay. So now that the scale is set up, what you want to do is to measure the wing. So again, if you go to the zoom option, you can zoom out using the right click. So you zoom out a bit, and you can use the hand tool to actually go over your wing again. still a bit too big. There you go. So that what I want to measure, I want to measure all the different sections of the wing. But let's start with one that is pretty straightforward and kind of easy. So I'm going to measure this area here. So this area here, you remember, is the L4 and L5. So I can already write down here in my Excel file L4, L5. Yes? And you can go back to the wing and you can use this polygon section. So you press that one. You can scroll using your mouse or the pad in your laptop. And now you want to define this particular section using that function. So you start clicking once, and you put these different dots all along, around the perimeters, if you want, that define the region that you want to measure the area of. So I'm going to do it rough. I would suggest that you put a good number of these dots. So I need to be careful here. There you go. So perhaps you want to put more dots that I'm demonstrating here in this video, just to make sure that you measure the correct area or the area as precisely as you can. Okay, so then when you finish, so you should have a polygon, an irregular polygon like this. If you are not happy with all the points, you can go and change perhaps the position of some of them. Okay, so when you are happy with the area, when you're happy with the defined area, then you go to Analyze and Measure. And here you have the area in this new window. So now you go back to your Excel file. So the area that you measure is this one, is 1.010. So you write it here, 1.010. Yes. So this is what we measure, 1.010, 1.010. And you want to make sure that you save your data. So just to show you, I would suggest that you save the file on the OneDrive. So then even if your laptop breaks down or something happens, your data is saved. Okay. So obviously this is not finished. What you want to do now is to repeat the same for the other section, so you can measure the area of all the different part of the wing. So because it will be the same wing, so what you can do, you can copy or if you want, drag down, because it will be the same name, the same genotype, the same sex, the same symmetry, and so goes on, but you will have the different parts of the wings here and the different areas. Okay, and every time make sure that you save. I hope that this makes sense and this will help you in your data analysis. I will share with you in another video or later on how we can statistically analyze the data and how we can make the most of it, given that you will collect a lot of information about the wings.